Good morning, Pete here from Kaylor Motor Works. So I went out yesterday and found or picked up an early 1980s or 1981 Kaylor adapter with a compound wound China motor attached to it. It does unfortunately have a shaft that sticks out the far end, which makes it a little bit more difficult to mount in the Volkswagen. But chances of using that shaft are slim, so that shaft may end up eventually coming off. This thing had been sitting for a long time, has not run in a long time. Exactly how long, I don't know, but probably somewhere in the maybe late 80s, where it was just kind of parked and hadn't seen anything for a long time. So I needed to find out if the motor actually worked. There were a couple broken pieces on it. So this wire here was replaced, and what I ended up doing is I ended up getting my larger battery pack, which is right here. It's 111 volts worth of power, which is way too much for this motor right now. Unless it's connected to a controller. So these were set up as non-controller motors, and just your speed control was done with mechanical contactors. And double pull, double throw contactors. So you start out with like 12 volts, and it puts a 36 volt battery pack into three different modes. Got 12, 24, and 36. And or something like that. Anyway, so you split it up, and you start out in 12 volt mode, and it'll get you going. You got 4 speeds, and then you hit another switch, and then you can actually go 4 more speeds if you want, and just kind of keep going through. But by the time you're up at the 36 volts, it's a lot of torque, and your car's just kind of humming along, using the gears to get you moving. So these are basically torque-driven setups. But because this is a compound wound motor, it can be both shunt and series at the same time. And that's what it is right now. With low voltage and high current, this thing's just got a crap load of torque. And so if you have a controller, you can go from very low voltage to very high voltage. It doesn't dump 100% all at once, but it'll handle high current. And so these batteries here can dump a ton of current real fast, and this thing will just go. It just goes. It's even so right now it's 15 volts, and you're going to see this thing just kind of lurch and jump because of the high torque. So I'm going to move this board up underneath the motor at the moment here, because I think I'd like it to be on this thing. When it gets ready to go, it's gonna rock pretty good. So that should help a little bit there. But earlier, what I did is I put 115 volts to this crazy machine. And just manually just touched it, and it just created a big plasma ball. Pretty much null and void, and I'm not going to do it again. It just threw a great big huge spark. The motor did run, but it was like way too much torque at that instant 115 volts and full amperage. So now I've got a contactor set up in the system, and now all I got to do is just turn the contactor on. And that's at 15 volts, mind you. So I'm going to set this up and do this again at a little higher voltage. We're going to check it out. Let me get the battery set up. So now that I have the voltage changed, I changed it to 31 volts. So it's going to lurch even more because there's more current. And a much higher speed. And that's just humming along nice. .31 volts. So let's see with it running how many volts it's showing. So 31.6 volts. I do not have a current meter to hook to it, so I don't know how much amperage it's drawing, but probably not a lot, just because it's a no load. So I think at 96 volts, this thing's just gonna really be a super powerful setup. And so I'm gonna clean it up, and we're gonna put this in one of the Volkswagens. Either the Bug or the Bus, one of the two. So just wanted to show you. Let's do one more test, and I'm going to do it with even higher voltage. We're going to go all the way up to 50 something volts here, and I'm not going to be able to hold it back very well. And so now we have 55 volts. So So that's at 55 volts. So these motors, oh, hang on. So these motors do not have an internal fan. And need to be piped in air to run through the motor and out the front. To keep them cool. Some motors have internal fans to do that. This one does not. So anyway, that's what I have. It's a Kaylor. There, let's swing this around here. You can see the name right there on the adapter plate. Here. Guy by the name of Roy Kaylor came up with that design to initially use the old military starter generators attached to it. And this particular China motor has the exact same mounting pattern and shaft configuration up front, except this one's got a solid shaft all the way through, where the starter generators do not. Starter generators are literally a clutched shaft, and it would take a lot to cause the clutch to slip. But I like this setup because it's a solid shaft, and it's more like a series motor. But this one we get to utilize both the field and the series at the same time, and so that's what I like about this guy. And the series, the shunt part will basically give you good speed control, and the series gives you very high torque. So you get, and it kind of adds to with the shunt and the series together, versus just a series or versus just a shunt. So standard just plain shunt motors, you wouldn't really want to do this. It needs to be series shunt compound. And the starter generators they're compound wound, but the shunt is built in to it. And I've successfully used those as a setup with a standard controller as well. So that's the better way to actually run those, except by doing that you don't get any regenerative braking function, or what they call plug braking. This motor I could probably figure out how to set it up to get plug braking with a modern controller. So what it might end up doing is disconnecting the controller while it's in braking mode, and then hit the throttle again, and it just starts right back up. Disconnects the generator and starts back up as a motor. So anyway, that's where we are at the moment. I just got this yesterday, and I'm gonna go show you one more thing here. So hang on, because it's gonna get better. So the other thing I picked up with the Kaylor motor was this twin cylinder. It's like a military DC generator. Are you done? Are you done? So this hasn't been run for a long time either. It is pull start, not electric. Bummer. But this was used in one of Roy Kaylor's hybrid setups, because this generator will output 24 volts. And at 24 volts, you saw that one motor, actually even at 15 volts, did really well. So you could cruise at 24 volts, no problem. And so this, if it was running in your vehicle, would output enough from the generator to allow you to cruise with your electric motor. This is a tiny little engine, maybe 10 horsepower. It's V-twin, has a magneto, so there's no battery needed. And so we're going to try and get it running again. And there's also a set of contactors down here and shunts. And the shunts are for watching your amperage. And then you got two switches. One switch is for generator, and the other switch is for the motor. So this was all connected in a single vehicle as a hybrid. Now this is different than a hybrid. Another hybrid thing that he came up with was using a Tecumseh 10 horsepower with a shaft that goes down the center like a lawnmower engine, where the blade's on the bottom, the shaft runs vertical, and then with that was two pulleys, and each pulley ran an alternator that output like 12 or 24 volts each, and then run that into the electric motor, so you can cruise as a early hybrid. And this is an indirect, so your engine generator is separate from your electric drive motor. And so if your electric drive motor craps out, this isn't going to help you. But that's basically how they set it up. So anyway, don't know if this works, so we're going to have to do some work on it. Get the pull start working, see if we can turn it over. Oil's good, I do know that. And then check the carburetor, fuel pump, all that stuff. So I don't know if the fuel pump's working either, so we'll have to deal with that. But anyway, with that, that's what came along with this. And so I'm going to deconstruct this, and we're going to seriously clean it up and see what goes where. And there's a big rectifier thingy here, or whatever you want to call this thing. So, not sure what. So this is all bent, and there's contacts there that, so I'm not sure what that is about. So I don't know. Might be incomplete. Looks more like a potentiometer. It's like a giant one. So that's possible. And that would be interesting. So we'll see. We'll figure it out. And one more thing coming up. Hang on. The other bit is that motor. It's a Kaylor motor, and that has a quote starter generator, but this was actually used as a generator, not a starter. And it too will connect right up to the adapter plate. And I've actually had this in the car, and I actually had this set up with a controller running my Karmann Ghia, 72 volts at 62 miles per hour. So this one definitely doesn't have the torque like the other motor that we just saw running. And then down over there is another starter generator, and that one is a starter generator. And those two were also attached to these adapters and used. And so I have a pulley on that one, and I was going to use that as a generator. Didn't seem to generate any power, but maybe that was only because I didn't have a load on it. So I needed to have a load, needed to connect it to a motor. And that should be a self-excited DC generator. And that would output like 32 volts, something like that. And I'm more apt to use one of these as a generator versus the other one connected to that engine out there that I just showed you. Just because this can put out more voltage and up to like 200 amp output, which is plenty to cruise. And if you needed more power, then your setup would suck power from the generator and the battery pack. So you will still have a battery pack with the hybrid. So one more to go. And here we have a Kaylor adapter plate. Oh. And this one actually came with another adapter plate. Two-piece to put a larger motor onto that. And I want to see if I can actually do something with this and put one of my AC motors, my induction motors, on this. Maybe. But I'm thinking that this is too far away, so I'd have to have a different connector or coupler between the motor and the flywheel. So we shall see on that one too. But But anyway, just mainly wanted you to see the Kaylor. So this has the dual bearings in here, but it does not have the center piece that holds the for the flywheel. It is basically the end of a Volkswagen crankshaft that's been set up and turned to fit inside and fit with circlips so it doesn't come out. And it does well, so I'm not worried about that. And it's got 2 bearings instead of 1, which is even better. So that's it for now.